AWS Lambda is a serverless compute service that lets you run code without managing or provisioning servers, creating workload-aware cluster scaling logic, maintaining event integrations, and managing runtimes. In short, AWS Lambda is Amazon's answer to serverless compute services that allows you to run code with zero administration of the infrastructure required to run it. AWS Lambda allows us to upload the code to it and then takes care the compute execution power required to run the code. Embracing services like this, which requires little or no infrastructure maintenance from an application developer, is usually termed as serverless. Hello everyone, my name is Rahul and welcome back to this YouTube channel. Couple of months back, I joined OFX and I've been working with the global currency account team. The team is mostly on Amazon Cloud and building applications on it. Now, I am quite new to this and much of my experiences has been with the Microsoft Azure Cloud, where I am also a Microsoft MVP. But this calls for some additional learning and I'm really excited about it. My core programming language is still C# and mostly ASP.NET. In this video, let's see how to get started with AWS Lambda as a .NET developer. I will show you right from starting a new project, the tools and packages available, how to debug and run AWS Lambdas on your local development machine, and then we'll also deploy this to the AWS environment and see it function there as well. Finally, we'll have a quick sneak peek on how AWS Lambda works internally and what happens when a Lambda is triggered. So without much delay, let's jump right into it. Let's head off to Visual Studio to create our first AWS Lambda project. I have Visual Studio open here. I'm using the 2019 version and on the latest update. Visual Studio does not support creating AWS Lambda or in fact any projects for the AWS cloud by default. To do this, we'll need to add an extension. So let's skip creating a project in this page and choose the Continue Without Code option. Once that's selected, we can go into Extensions and click Manage Extensions. Here, we can search online in the box here using the AWS Toolkit keyword. This lists back the AWS Toolkit for Visual Studio 2017 and 2019. Select that and install this for your Visual Studio. Since I have it already installed, it shows this green tick. If not, you will get this download or the install button. So make sure you get this and then you might have to restart the Visual Studio IDE again. Once that's done, let's close this. Let's go to File, New Project. Now you can see here there is an option for AWS and also it gives you different options inside here. So let's choose serverless because that's the kind of applications that we are going to build. It gives you different options right from building a serverless application or a Lambda project. Let's choose the AWS Lambda project .NET Core C#. This is the most basic template. So let's select that and click Next. It asks you to give the name. Let's make sure it's in the appropriate location and then give this a project name. Let's keep this as myfirstlambda and click Create. Now this prompts you to select a blueprint. Blueprints are Lambda projects that contains some getting started code. So it has some things already wired up. The different options you can see here is to start with an empty function, create something to integrate with Dynamo or SQS, SNS, .NET 5, etc. Let's choose empty function and see how everything works together and build it up from scratch. So let's click Finish and this will create the new project for you. The AWS Toolkit that we just saw for Visual Studio is also available for other popular IDEs. Like this one here, it shows the JetBrains Rider one, and there's also one from Visual Studio Code and many other IDEs out there. So you can pick and choose the toolkit based on the IDE that you are working on currently. So let's go back to the project. The project is created successfully and we can see it has the function.cs file which is of importance to us. Let's double click to open that and we can see a function handler method which simply takes in a string input, the Lambda context, and then returns back the string in an uppercase. So this is a simple function which takes in any string and returns an uppercase variant of that. If you scroll up, we can see this is also attributed with the Lambda serializer attribute. This enables to serialize and deserialize the string content coming into the Lambda function. In here, by default, this is set to a Lambda JSON serializer. If we open up the dependencies, we can see two packages, that is the Amazon Lambda Core and also one for the Amazon Lambda serialization. So this Lambda serializer and the iLambda context that we saw is coming from the core library, and the default serializer is coming from this serialization library. So these are two NuGet packages that are already added in with the project template. If you right click the project and go to properties, we can see the target framework is default to .NET Core 3.1. At the time of recording this video, the .NET Core 3.1 is the officially supported version of .NET. You can read more about the announcement for 3.1 support in this blog here and the various things that it supports. I'll make sure to put a link to this in the description below. Now, even though we have .NET 5 and even .NET 6 almost there, AWS Lambda still does not support it out of the box. This is because .NET 5 is currently under the current support level, and the AWS Teams policy has been to support LTS versions of languages and runtimes. So that in .NET world is currently .NET Core 3.1. The next LTS support version of .NET is .NET 6, and we should be seeing that soon on AWS Lambda as well. If you want to create the projects using the command line, you can also do that. For this, you will need to first install a set of templates using the .NET tool. So if you go to this link, which will be linked in the description below, you can get the required commands. So if we copy this .NET new -i Amazon Lambda templates and run this in your command line, we will have all the templates using the .NET CLI tool as well. Since I have this already run, I have it installed. Now if I switch over to the command line and use the .NET new command, I can see all the templates that's supported by this CLI. If we scroll up, I can see that we have the Lambda functions and the runtimes in here as well. To create the project very similar to the one we just created, you can use the lambda.empty function. However, note, this will also create the test projects by default, but it doesn't differ from what we have right now. So let's come back to the IDE and use the application we created from there. To run this application on the local development environment, we can see there is already an option set up here using the mock lambda test tool. So how is this populating up here? This is a profile that is added as part of the project under the properties and the launch settings file. This is very similar to the profiles that get set up in ASP.NET Core applications. If we look at this, we can see there is a profile with the name mock lambda test tool, which is appearing up on that run button, and it specifies it's an executable command, specifies the port, and also the actual executable that needs to be run. It points to the .NET Lambda test tool, which is getting installed as part of the toolkit. Let's run this to see what exactly happens. Let's click this or press F5 to run it. Now this by default launches a console application, which is the Lambda test tool that we just linked to in the profile, and this starts it up on the local host port 5050. So now we have an application that's listening to this port, which we can hit to. So let's navigate to our browser where this is getting automatically launched. So here we can see that there is the AWS.NET Core mock lambda test tool. This allows us to run the lambda function code inside this tool, and the IDE is automatically attached to the debugger. So let's switch back to the IDE, navigate to our function.cs, and make sure to put a breakpoint up here. Let's navigate back to the browser. Here we can see the config file, which is the AWS Lambda tools default, which is part of our project. It also specifies the function and the credential profile. So how is this function name coming up here? This function name is coming up from this AWS Lambda tools defaults.json. If we navigate back to the code and to the JSON file, we can see this function handler exactly the same as we just saw. The function handler is in a specific format. If you see, it specifies the assembly type first and then uses a double colon and then specifies the full namespace of the class, that is myfirstlambda.function in our case because it's inside the function.cs class, and it also specifies the function name. In our case, this is function handler. This is how the function handler gets specified. If we want a more friendly name to appear in there, we can use the function-name attribute and give it a friendlier name. So let's call this myfirstlambda. Let's save this and run this again to see if that gets effect. It launches the Lambda tool again, and then it browses automatically to localhost 5000. Here we can now see the function is named myfirstlambda. Let's enter in an input. So in this case, it expects a string. So let's say hello lambda, and then execute this using the button up here. So this hits the debugger as expected. it gets the input, which is hello lambda, and calls the toUpper function on this. It returns the result, and we can see this inside the lambda test tool. So if we scroll down, there is a response section down below, and we can see the toUpperCase string for the string that we just passed in. If we navigate back to the code, we saw initially we had specified a JSON serializer. This means we should be able to take in a JSON data input as well. To see this in action, let's create a class to represent the JSON structure. So let's create a public class and specify myData, and then add in a new property. Let's name it name, which is a string property. So now we can update this string to be myData, and then also call this as data. To start using the myData class, let's update this code to reply hello and the name. So let's use string interpolation and specify data.name, and then call the toUpper on that as well. So now in this function, we have the function handler taking in a type of myData, which has a name property, and we return back hello and that name in uppercase. Let's run this again to see it in action. We have the mock lambda tool running. So let's pass in the input. So let's specify the name attribute on the JSON and give my name in this example. So let's click execute function again. The function handler is hit. If we expand over data, we can see now this has the name Rahul. So let's return back the response, and this should show appropriately inside the response. So here we have hello Rahul in uppercase as expected. The lambda serializer attribute right now is applied at the assembly level. This means any function that's part of this project is going to use the same serializer. You can also specify the serializer at a function level. So instead of specifying it at the assembly level, let's remove this from here and specify it right above the function that we need. Since this is at a function level, we no longer need the assembly attribute in here. So let's remove that, and this is going to function just as before. So let's run this to see this in action. I can pass in the same content. So let's say name and pass in Rahul, and then click execute function. Now this also uses the default lambda serializer because this is attributing this current function. Let's hover over data, and we can see the value populating as expected. So let's continue execution, and it works as expected. So you can use this if you want different serializer and if you have multiple functions in the same project. We will see how we can do this in a future video. Now that we have the lambda function running and working locally as expected, let's see how we can deploy this to an AWS environment. The easiest way to do this from Visual Studio is to navigate to the project, right-click, and choose the Publish to AWS Lambda option. However, in a real-life project, I would be setting up a build deploy pipeline. But that's a separate topic for a completely different video. So let's use this for now and see this in action to just get started on how things work. So let's choose the Publish to AWS Lambda option, and this prompts up a dialog. Here, you can see I already have a default profile set up. Now you can set up one for yourself on your local IDE using this plus button in here. All it asks is an access ID and a shared access key. This is available once you set up the AWS account. Now, if you don't have an AWS account, you can check out the AWS free tier option, which gives you free services and things to try out for an year. This is quite useful, and it has almost all the services in here that is available for free, but in restricted amounts. This is good enough to learn and give things a try. So I am using this for my current learning and the videos that I am making. So let's navigate back. Once you have the account profile set up, now you have the other options. So you see here, there is a region that this is getting deployed to. Now you can choose different regions that's available. So let's choose Sydney in this case. Now the package type by default is zip, and it specifies the Lambda runtime as .NET Core version 3.1. It has also picked up the name of the function from the configuration file and also the other settings in here. You can see that the handler method is also getting specified inside here. This is what is used by the Lambda to invoke this particular function. So we have the breakdown of this long string, which is an assembly, type, and the method like we saw before. Let's click next to move on. Now this prompts you to select an IAM role for the AWS Lambda to execute. Now this has a lot of different templates available by default. So let's choose the AWS Lambda basic execution role. So this gives us the permissions to write to CloudWatch logs as well. So let's select that Let's ignore the other settings and leave it to their defaults because I'm not using it in the current video. Let's click upload and that starts uploading this function. Let's uncheck this so that it doesn't automatically close the wizard. If we expand this, we can see the log of actions that's happening to create the AWS Lambda inside here. As you can see, it first creates the Lambda role and then it executes the dotnet publish command, which publishes the output of this project, and then it zips up into a folder. Now you can see the different files that's getting zipped up, including a runtime config file, which is automatically generated by this template. So if we navigate off to this folder, let's copy this path to the publish folder and navigate there. We can see the runtime config.json file in here. Let's open this up in an IDE, and this specifies the runtime that's used by the AWS Lambda. So here, since our project is using .NET Core App 3.1, this specifies the version as that. We will see a moment later how this is getting used by AWS Lambda. Let's navigate back to Visual Studio. The publish is successful, so let's close this dialog. And we can see that it has automatically launched up the function myfirstlambda inside here. Now if you want to navigate to this function again, let's say if this was accidentally closed or not opened, you can go to it by View and then going to AWS Explorer. This explores all the different things that's there in your AWS account. So right at the bottom of this, we can see AWS Lambda and the myfirstlambda. Double-clicking that is going to open that same window again. Now this is looking at the deployed version of the function in the AWS runtime. If you were to specify the sample request, let's say a JSON input with the name property, and specify the name again, let's say Rahul, close this, and then invoke this function from here. This is going to actually invoke the function on AWS Lambda. So you can see here in the below the log output, which gives in a request ID and it ends it immediately. It also specifies the duration that the function ran for. On the right side, you can see the return message, which is the capitalized Hello Rahul message. If you want to see this from the AWS console, we can navigate to a browser and navigate to the aws.amazon.com. This prompts you to log in to the console. So let's sign in. Once signed in, you can go to the Lambda section. For me, since I had recently visited it, it comes up here. If not, you can search it inside this box using the Lambda key. And then it prompts that service, so select that. Make sure you have the correct region selected up on the right so that you can start seeing the function. So use this to wherever you deployed it into. So since mine was Sydney, you can see the myfirstlambda function is appearing up here. It shows that its the runtime is .NET Core 3.1 and also says it was last modified 5 minutes ago. So let's select that to navigate into it. There are a lot of options and configurations that you can set from this Lambda function. I'm still exploring this and will cover that as part of a separate video. For now, the only thing that we are interested in is to test and invoke this particular function. Before we do that, let's navigate to monitoring and we can see that there is CloudWatch metrics. So if we click the View Logs in CloudWatch button, this takes us to the CloudWatch that's specific to that particular Lambda function. Since we just did an execution from Visual Studio, that record comes up here. I had earlier used a similar function name to test for this video, which is why these two records are appearing up here. If we navigate into this record, we can see the same log request that we saw in the Visual Studio console. So this says the request ID and it ends it immediately. We can do additional logging inside the Lambda and that will start coming up here. I will be doing a follow-up video on logging practices, so we can see more about it in that video. For now, let's navigate back to the AWS Lambda and then we can use the test button in here. To trigger this, so this specifies a JSON. So let's remove these properties and specify the name property and a name. Let's give Rahul again. We can create a new template, so we can specify a name as well. In this case, let's specify my data and then click create. So this has created a template which I can now use it from the test button. So invoking this is going to invoke this function with that particular data. So if we expand the details, we can see the response back, hello Rahul. If we want to create a new test data, we can choose configure test events and specify the new data. So let's specify create a new test event specify a name for this. Let's say my data new, and specify the name as, let's say, Rahul new. So let's click create, which creates a new test data event. Now we can switch between the two events inside here. So let's select the new one that we just created and click test again. So this shows up the return message as hello Rahul new. So you can save as many requests that you want to test inside of here. If we scroll down and navigate to the configuration tab, you can see that the only thing mentioned here under the runtime settings is that the runtime and also the handler name. So how is AWS Lambda invoking this particular handler using just a string? Now we saw earlier that this is a fully qualified name using the assembly type, the full namespace and the class name, and also the function name. AWS Lambda supports multiple languages through the use of runtimes. Now, the runtime provides a language-specific environment that runs in an execution environment. So in this case, we uploaded it using the zip file, so this is specified inside a config file, which we earlier saw. The runtime relays invocation events, context information, and the request and responses between the function code and the AWS runtime. So it sits in between the code that we write and also the AWS Lambda infrastructure. So it communicates between these two and allows to execute our code. Now for .NET, the out-of-the-box supported runtimes are currently .NET Core 3.1 and also 2.1. Now this, like I said before, it will be updated when the next long-term support version of .NET comes out, which the new one is going to be .NET 6. Now with this string defined here, the .NET runtime internally uses reflection to load this assembly, finds this class name, and invokes this function with the parameter that comes in the request. It also passes in the Lambda context for any additional information that's required. If you are interested to learn more, there is an AWS Lambda runtime support library which is available on GitHub. So you can look at this to understand more of the internals on how the Lambda infrastructure works and how it invokes the Lambda code that we have provided. I hope this helps you to set up your first AWS Lambda project, get it working locally, and also deploy it to an AWS infrastructure. If you created the AWS free tier account, make sure not to be running resources for a long time because then it might start charging you. So I often delete it immediately after I'm done with it. In this video, we manually triggered the AWS Lambda using the Visual Studio and also the AWS console. However, in real life, we would be using external automated triggers to invoke our Lambda functions. I will cover this in detail in an upcoming video. If you like this video, please make sure to hit the like button. Do drop in the comments if you have any feedback or questions. I'll make sure to answer them. If you want to be notified of future such videos, please make sure to hit the subscribe button. It really helps me to grow this YouTube channel. Thank you and see you soon.